Hello, everybody. Chris Neidl here. Thanks, everybody, for joining us for this latest episode of This Is CDR. This is sort of a relaunch. Many regular viewers are probably tuning in again. We've had 103 episodes over the last couple of years, and so we're picking that up again with a brand new season. I'm your host for today. My name is Chris Neidl. I'm one of the co-founders of Open Air. I'm often in the backstage here for This Is CDR, dropping links. And really excited for today's program. And before we get into the actual session at hand, we're incredibly excited to have the folks from Capture6 with us today. Just wanted to give you a little bit of a background on the program and Open Air, and then I'm going to hand it off to my co-host, Tank Chen, who will introduce our guests. So just to get started here about Open Air, I know we have a number of people tuning in today that are either active members or certainly familiar with Open Air. Open Air has been around for about 5 years, and we're a distributed all-volunteer network that is committed to advancing carbon dioxide removal worldwide through volunteer action. And our programs take a number of different forms or fall into what we call different domains, and these are the main areas that we are active in, and most of our connection happens between members on a platform called Discord, which is kind of like a Slack. I'll have Tank drop a link if you want to join that. That's a good place to come in. You can seek me out there and I can give you a tour. But in terms of those domains that we're involved in, that most of our activities are focused on, there are 4 of them. Advocacy, which is focused on the development, introduction, and activism for pro-CDR policies at the subnational and national level, particularly at the subnational. We have some really interesting R&D or maker or citizen science projects, and these involve our members getting together, developing technologies and prototypes, or doing interesting forms of field research related to CDR. Education, of which This Is CDR is sort of our flagship program, but these are activities that we do that are related to generally raising awareness about carbon dioxide removal for a variety of audiences, and also enterprise. Some of our members are active in trying to directly support carbon dioxide removal business models or businesses or projects. And just to give you some examples, I think what we'll do each week at the beginning, just give a little shout out to one example of a type of project that falls under each of these domains, just to give you a flavor. One, for instance, for advocacy, we have a number of different pieces of legislation in the US that we'll be working on in 2025. One real exciting one that's getting close to getting written up is a biochar focus that's sort of a demand support for biochar in New York State. So if you're interested, if you're in New York or interested in biochar and want to find out more about that, definitely join our Discord. And again, that's one of several different advocacy initiatives that are going to be going on currently and into the next year. A great example of an R&D project that I'm very proud of and very involved in is called Epiphyte. And this is a miniature open source direct air capture machine that some of our members have developed. We built our first one last year at the University of Pennsylvania's engineering lab. And now we're building the second iteration of that at UT Austin, where I'm based. We've already ordered the parts. This group meets up on Wednesday afternoons. We do a live stream that's planning. Anybody can join it, but we'll be building the next version of that over the next few weeks. So very, very excited about that. Good example of an education project that we do in addition to CDR is CDR AI. And this is a large language model, or LLM, similar to ChatGPT, that a group of Open Air members developed. And it's sort of a ChatGPT for CDR only. It's loaded with over 700 peer-reviewed or government data documents related to CDR. So it's a great place for a new learner about CDR to, pick up some of the basics, or for people that want to do a deep dive into particular areas of carbon dioxide removal. So I highly recommend that. And a good example of an enterprise project is one that's also really hit its stride right now. And this is the Naka Valley Biochar Project. This is a small business that was started with Open Air support in Africa's oldest refugee settlement, Naka Valley in Uganda. And what we were able to do is crowdsource their biochar kilns, help fund their training, And now, literally just today, they got their final audit. They're producing biochar that are going to be credit worthy. And so this is a highly replicable project that can happen not only in Uganda, but anywhere in the last mile of Africa or other emerging economies. So hopefully that gives you a sense. Tank's dropped some links for some further information on these particular projects or missions. All right. So now moving on to our program for today, I'm really pleased to hand it off to my co-host and colleague, Tank Chen, who's going to introduce our speakers for today. We have Capture6, and they're going to be talking about their innovative water-positive direct air capture technology. So Tank, take it away. Oh, let me add you to the screen. That would be helpful.
Hey, Chris. Hi, everyone. I'm Tank. I'm a volunteer of Open Air based in Taiwan. Some housekeeping notes before we begin. Our format will be a short presentation followed by a few prepared questions, then moderated audience Q&A. So please type any questions you have into the StreamYard's comment box. Also, this event is being recorded. We will send the video link to everyone who register and also post to Open Air's website and YouTube channels. Our guests today are Dr. Luke Shore, co-founded Capture6 in 2021 and served as president. Prior to Capture6, he was the co-founder and executive vice president of the software company Capture6 LLC. Luke has worked widely across the fields of energy and the environment, public health, education for groups such as the World Bank, OECD, UNICEF, John Snow, and the American Institute for Research. He was a fellow at Harvard Center for Energy and Environment and completed his doctorate at the Harvard School of Education. Luke has a master in public health and master in business administration from Johns Hopkins University. And also we welcome Daniela Haman Nazaroff. She is a licensed professional civil and environmental engineer at the state of California with over 10 years of experience working at the intersection of water and air quality. In her current role as Director of Development, Daniela brings her wealth of experience to support the development of direct air capture, or DAC, and water recovery projects from their initial conception through to their operational phases. She currently leads Capture6 Project Monarch, a California Energy Commission-funded DAC project in Palmdale, California that is currently under construction. Daniela has led contract negotiation, environmental permitting, and engineering design for the project. She further supports the company through commercial development for offtake of CO2 and other green byproducts. Prior to her work at Capture6, Daniela worked as an environmental consultant, implementing large-scale environmental remediation projects to clean up groundwater and soil vapor contamination. In addition to overseeing engineering design, managing construction projects, and conducting field investigations, she led community relation efforts through hosting of community meetings to keep the public informed of the environmental health risk and mitigation. So Luke, Daniela, welcome to the show.
Thank you, Tank.
Here,
Chris.
Great. And Luke, will you be presenting first? I can share your slides right now.
I will be, yes.
Great. And if folks, Tank had mentioned, please use the comments bar if you have any questions. Put those in. Again, there will be time as we get towards the top second half of the hour for us to ask those questions directly. So please do add your questions and comments.
Chris, are you
I have Daniela's slides that are loaded up, but if you just click on the present button on the bottom there, and again, like we did before, just click on your presentation and then I'll pull it up and you can go from there.
Okay. Okay.
There we go.
Okay.
All right.
All right. Can everyone see these slides? Hello?
Yep, looks great.
Okay. Okay. Sorry. So what does water positive direct air capture mean? Capture6 is a DAC company that was founded almost 3 years ago. And we had a theory of scaling direct air capture, and that theory is that we needed to create some co-benefits to CDR. And by creating those co-benefits, we would have a pathway to scaling CDR in a cost-effective manner. So many of you who frequent this show would know that the ambitions for carbon removal are very significant and are orders of magnitude beyond what the world is currently removing. And so, this is an audacious target, but it's a necessary target. And of course, while scaling CDR, there's the other urgent requirements to rapidly decarbonize and to build climate resilience and adaptation. So, doing all three of those is kind of like, keeping three spinning plates going at the same time. And at Capture6, we believe that part of the solution is to make these things not oppositional to one another. That is, if you invest in decarbonization, you are making a choice not to invest in CDR. Or if you invest in CDR, you're making a choice not to invest in climate adaptation. But we want to make these things synergistic with one another. So this is a picture of water. Obviously, when we think of climate change, we think of carbon and heat, but some of the most direct impacts that people face is often through water, and carbon and water are intimately linked. Obviously, as the air becomes warmer, it can hold more moisture, leading to increased likelihood of these types of floods. The converse is also the case. In the upper left part of the screen, this is from Brazil, and this is the first time in recorded history that these three rivers in the Amazon have all been dry. So, again, water becomes kind of a key impact, whether it's too much or too little, that is partially a consequence of climate change. So Capture6 mission is to deliver large-scale and water-positive carbon removal. And in this case, we feel like, just as in a treatment for a health condition, you want to address both what are the symptoms of that condition, but also what are the cause. In the same way, we think of CO2 as kind of the primary cause, and the symptoms are water and its manifestations. So this is kind of how we think about our benefits, is that we can remove CO2, we can produce water, we can generate green chemicals, and then through that we can deliver low costs for all of the different benefits. How do we sort of technically enact that vision to create kind of water positive DAC? Well, the key in that is salt. And so, salt is not really the mineral that gets discussed when people talk about, the new clean energy economy. People will be much more likely to talk about, lithium or some other mineral. But salt is really ubiquitous, and as basically everyone in the world knows, not enough salt is a bad thing. Too much salt is a bad thing. So, everyone who's ever added, salt to their food, which is probably every adult on planet Earth, knows that no salt is not tasty, and too much salt is inedible. And the same at a larger scale happens with places all around the world. There's places with a deficit of salt, and then there's a lot of places with excess salts. And excess salt is often the result of human activity. And it is also the result of climate change itself, as you have seawater incursion of seas that are actually kind of contaminates freshwater supplies. So all this creates a demand for basically processing salt. And in our process, what we do is we strip out the sodium, and using electrochemical methods, we split the water molecule into hydrogen and hydroxide. We combine the sodium with the hydroxide group, creating sodium hydroxide. And then we use cooling towers to basically bond the sodium hydroxide, which is a strong base, with the carbon dioxide, which is an acid in the atmosphere, creating sodium carbonate. There's many permutations on our process, but at a high level, that's kind of what it is. And that's why we have the ability to also generate fresh water, because we are using a source of water, a brine, that is not usable for the typical things you would use fresh water for. So what are these sources of saline water? There's quite a few of them. And interestingly enough, a lot of different energy transition projects themselves kind of create further brines to be dealt with. So efforts to hollow out salt caverns for long-term hydrogen storage, as is happening in Utah and various places, creates massive brine ponds. Capturing CO2 for injection through CCS basically results in brine that kind of bubbles out to kind of neutralize pressure. Geothermal activity is producing brines that have to be managed. And of course, as the world tries to be more efficient with water, there's more processing of wastewater, and that also requires dealing with salt. So there's many opportunities to try and the typical methods for dealing with brine is what's known as brine management. And as the word implies, it's you're effectively managing the salts, but you're not fundamentally doing anything with them. So you for inland facilities that process salt, a typical approach is to create salt evaporation ponds, which are very expensive endeavors. And when the water evaporates from those ponds, then the crystallized salt is loaded into trucks and put somewhere. So that's a very expensive process, but more importantly, it doesn't actually change that salt, nor does it yield anything of economic benefit. It is fundamentally a waste that is being processed. So, kind of at the heart of what we're doing is transforming this cost that has no benefit to anyone, which is brine management, into something that is really brine transformation, a chemical conversion of that salt. Now, on the other end of our process, we can do a lot of different things. And what precisely that is depends upon the composition of those brines and what is the kind of outputs that the group that we're working with is interested in. So if there is lithium in that brine, one of the first steps typically to getting to the lithium is to actually process salts. So this creates a nice economic synergy with direct lithium extraction. There's also the possibility of producing pure CO2 and various other kind of outputs that in different circumstances can have economic value. So at this point, I'm going to hand this over to my colleague, Daniela, who's going to kind of take this high-level discussion of our process and tell you specifically about one instance that we are pursuing in California.
All right, thanks, Luke, and thanks everyone for joining in. I'll be talking about one of our project sites in Palmdale, California. And this is at a Pure Water Antelope Valley facility, which is going to be the first fully integrated water management and carbon removal facility of its kind. So we've been partnering with the Palmdale Water District to take brine from their advanced water treatment, which is recycled water essentially, and process it for atmospheric carbon removal and increased water recovery. This demonstration facility, which is currently under construction, has been awarded an $8 million grant from the California Energy Commission, and it will help provide kind of proof of the technology prior to expanding to full scale. So Palmdale Water District's mission is to provide high quality water at a reasonable cost. And their Pure Water Antelope Valley project is necessary to increase Palmdale's water resiliency. So if you folks aren't familiar, Palmdale is located in the high desert. It is very far from the ocean and imports the majority of its fresh water for its citizens. This means it is subject to, a lot of price fluctuation or kind of restrictions and rationing during times of high drought. And so this recycled water project has been a key effort to try to increase their own sort of native water source by recycling water that they have used. Traditionally, when they do this advanced water treatment, as Luke said, the waste brine generated has to be managed through evaporative ponds. And in Palmdale's case, they were estimating a couple miles of pipeline and then about 72 acres worth of land used for the evaporative ponds. And by partnering with Capture6, they've actually been able to sort of alleviate that land use. The footprint of our facility is much, much smaller. And we've done some analysis with them, some third-party analysis. The lifetime cost savings for using Capture6 as a brine management tool will save the district, 20 to 40% in lifetime costs, which is really remarkable. Additionally, at the full-scale facility, we will be recovering fresh water. You can see up there 387 acre-feet per year. That we would return back to Palmdale so that they can, finalize treatment and distribute that fresh water back to their community. The project has a ton of benefits to the community. Like we said, increased water reliability, more control on costs from Palmdale's perspective, the reduced environmental impacts from, the land use reduction in kind of using land for brine ponds. It can be used for other things. Brine ponds also, as they evaporate, can emit hazardous air pollutants that get airborne and then sort of impact the local community that they're nearby. And then the demonstration facility that we are working on is also intended to be an educational facility. So not only for training of future operators and engineers, but also educating the public on, their water resources, climate change, carbon capture, and other aspects. So how do we get this built? The process of building an advanced water treatment plant along with this direct air capture system is sort of similar to any infrastructure project within California. It's regulated by Title 22 and it moves sort of slowly, but that is sort of the nature of the industry that we work in. Because recycled water is relatively new, or there's some regulatory nature to proving that the water is suitable for drinking water. The Department of Drinking Water in California requires this demonstration facility to be built and operational for about a year in order to prove that it can meet water quality standards. So that's why we are doing this demonstration facility. And as you can see on our schedule, we've spent, last year and a half doing design and permitting. We are currently in construction, so ground broke in September, and we intend to start operating in 2026. The demo will operate for at least a year and probably a couple years further, and then we will use that data to support the full-scale facility. And that we hope to be operational by 2030. So as I mentioned, integrating Capture6 stack technology, it helps Palmdale for water recovery, it manages their brine, and it saves them costs. We also, as Luke mentioned, generate some other chemical byproducts. In this kind of configuration and design, a couple of the key byproducts are hydrochloric acid and sodium hydroxide. And these are both chemicals that are used in traditional water treatment plants for pH management, disinfection, precipitation, and corrosion control, among other things. So there's a nice synergy here, again, that these byproducts that we produce, we can actually sell back to Palmdale to use in their water treatment process and sort of decarbonize different aspects of their process. So not only are we pulling CO2 out of the atmosphere, we are creating these chemicals that come from kind of green sources, essentially, allowing them to be used back at the facility and kind of decarbonizing the water treatment industry as well. In terms of storage, one of the unique things about our technology is that the output of our direct air capture, as Luke mentioned, is a carbonate solution. And that will likely be stored in a deep saline aquifer. We've been talking with the EPA kind of about geologic storage recently, and we're looking into kind of newer existing class 5 wells, which are for non-hazardous waste for this storage. And we just have more flexibility than some other traditional DAC facilities that produce pure CO2, which would require a class 6 well, which has its own kind of permitting and regulatory challenges. And we have that flexibility that we can use alternate storage mechanisms. So what does this look like from a larger scale? You can see on our left, the demo scale Project Monarch project is barely even a drop in the bucket in terms of moving us towards this, gigaton scale of carbon removal. Even the full scale facility is pretty small by what we need globally to make an impact in the carbon dioxide concentrations in the atmosphere. But this is the trajectory that we need to go through in order to reach those large scale facilities that we know are viable and kind of get that demonstration. The great thing about what we're trying to do with these partnerships is that there's a lot of flexibility for partnering and integrating in a lot of geographies with a lot of different industries to do this carbon removal and water generation that kind of are mutually beneficial for both the global climate as well as the kind of local economy. And we're not just looking at California. Capture6 is developing projects around the world. So these are our kind of current most active projects. We've got 2 in the US, 1 in South Korea, 1 in Australia, 1 in New Zealand, and 1 under development in the UAE. And again, like I said, we have the ability to integrate with various different industries. The Project Monarch example is obviously with water treatment, but there is desalination processes. There is mine process water that is very saline, that needs management. And so all sorts of different industries that work really well to kind of integrate and decarbonize both the industry as well as draw carbon out of the atmosphere. And so with that, I think we are on to our discussion section.
Excellent. Well, thank you so much, Luke and Daniela. That is really fascinating. I think there's some really novel parts of your value proposition there that we haven't seen before in this show. So really excited to have learned more about them. And we'll get into some detail on what that Palmdale facility is actually like physically as an object. So excited to get into some detail around that. But to begin with, one of the things we really like to do to kick off our discussion here at This is CDR is to really expose people to the fact that real, live, living, breathing human beings with very diverse backgrounds have come into not only the DAC space, but the CDR space. And I think that diversity is one of the sector's incredible strengths in terms of its creativity and accumulated experiences. And so to that end, we had heard a little bit in your introduction, but you both come to this from very different places. So I'm curious if each of you, maybe starting with Luke, who began, tell us a little bit about your journey to DAC and specifically to Capture6, and then we'll hear from Daniela.
Yeah. So this company was started during the pandemic, and so I was on a hike with my co-founder and our CEO, Ethan Cohen-Cole, and we just sort of said, oh, we should collaborate on something. And as we passed ideas back and forth, we settled on this space. And both of us have somewhat of a scientific background, but neither of us are like material scientists. So we came at this, more as a kind of financial problem, engineering problem, market problem, and kind of saw some things with incumbents that we thought maybe it would be worth trying something else out. So if we didn't operate at high temperatures, well, then we could use strictly renewable resources that were intermittent. If we used, technologies that were already kind of at high technology readiness levels, then we could get, EPCs that could build them and banks that could, be comfortable with those risks. If we could create something else of value besides CDR, then we wouldn't be reliant exclusively on government subsidies and the voluntary carbon market. So, kind of by looking at what we perceive to be some of the problems, we kind of backed into the space. And then, at that point, it sort of organically grew. And it's about kind of bringing, like any business, bringing the right people in. I have been struck in this space by how many competent, creative people there are in the space, and that is, as you say, one of its core assets. So as our team has evolved, suddenly it's less, hierarchical, myself and Ethan, kind of pushing things, but it's been more like the team is sourcing new opportunities, coming up with new ideas. And, that is really what is kind of propelling the business.
Yeah, and before we hear from Daniela, one of the things that's remarkable, I'm on one of the founding board members of the DAC Coalition. We have many different direct air capture companies, including you guys who are members. So we have a pretty good view of how this is shaping up. And Capture6 just sort of arrived out of nowhere, and not out of nowhere, but like, wow, here's this company, and they're moving close to getting a project done, and they have a novel technology here, not just the water positive part, but the slurryized CO2 that's non-supercritical. That's a huge deal. And Daniela, I think you really touched on that, give some flexibility. So I'm just curious, there's some interesting IP here, an interesting approach. And I wonder if you could just tell us a tiny bit about how you arrived at the Capture6 approach. Is this sort of rooted in some genius scientist at a university who's been writing papers about it? Or I'm just curious how the Capture6 technology sort of originated.
Yeah, we do have some smart people on the team. I'm not sure, I'm not going to use the label genius with anyone because I don't really use that label and don't find it helpful, but we have a bunch of very bright people. Obviously sodium hydroxide as a solvent has been used forever and ever. So there's nothing novel about that. Maybe it was novel to think that actually something as kind of pedestrian as sodium hydroxide could be effective. I mean, like a lot of startups, different realizations have kind of dawned on us over time. And so we knew that, the ability to process salts and generate some fresh water was a co-benefit from the outset. But what we didn't know is that actually there would be parties that would be more motivated by that than CDR. And that was, that led to kind of a marketing shift, right? But it also led to technology shifts where we thought, well, how can we recover even more water? Because at first we were just thinking producing a little water is an accidental byproduct. But, even in the slide Daniela showed, what was this figure, Daniela? 387 acre feet or something. I mean, if you envision an acre of water in a cube that's 387 feet high, like that's a lot of water. And so, I guess it's evolved. We do have kind of system level IP, both, granted patents and kind of pending patents. We haven't really tried to kind of come up with new membranes. We are doing a little of that R&D just because we have some opportunities to do that and kind of bringing some more of that capability in-house, but we're also very kind of agnostic on the subject. If someone's got, a great new, air contactor unit that is appropriate for this, this option, we're happy to kind of incorporate others' IP into it. We kind of think of ourselves first and foremost as project developers. And, secondly, as kind of technology developers.
Yeah, excellent. Yeah, I think that being able to approach a locality with this very salient value proposition that really folks care about. I mean, we can't really overstate, I think, how significant that is to be able to have a conversation that's not just about carbon removal. So that's really interesting. Daniela, fill us in a bit on your journey and how you made it into the crazy world of DAC.
Yeah, sure. So I started as an environmental consultant, and a lot of my kind of pre-DAC career was focused on cleaning up really a lot of legacy contamination. So we're talking about impacted groundwater from 50 years ago, 100 years ago type thing. And I always was I was cognizant that the work I was doing was important, but it felt like we were ignoring the most pressing issue of the time. This contamination, this legacy contamination has been there, and it's important to clean up and protect. But really, we're facing the climate crisis right now head on. And so I was always interested in kind of getting into that space. So Capture6, I think, really like we've mentioned, sits at the intersection of water and air, and that, spoke to my background. I was also really drawn to just sort of the mission of solving more than one problem at a time. There is, people rightly criticize DAC as, being energy intensive or various other things. And that is all true. But if we are solving another problem that already exists, and there is carbon removal from it, that is really, I think, the right way to approach the kind of carbon removal space is obviously not create new problems, but try to solve as many as we can kind of in one fell swoop.
Excellent. Well, I have a few other high-level questions, but we're getting some really good ones in, actually, from our audience, as is usually the case. We have a very smart, maybe not genius-level audience, but sometimes they give that impression. So I'll get to those in a second, but before I do that, and I'll bring up Tank when he's ready. Just one, I think, that is really interesting at this point to reflect on. I'm kind of an old timer in CDR. By CDR standards, I've been in the field for about 7 years. And when I showed up, it was a bunch of whiteboards and academics. And now here we are many years later, where there are, by most counts, dozens of direct air capture companies alone with radically different forms of technologies focusing on different business models and geographies. So I'm just curious, as an insider who's trying to make DAC happen in the real world, I'm curious if you could just share some of your thoughts on what are some of the sort of surprises or sort of changes that have happened in the DAC space since you've arrived in it that, again, have sort of maybe surprised you, either positive or negative indicators? I'm curious if you have anything to share on that.
I could share something that touches on one of the comments. So there's a comment from Ben Lichtenstein on basically additionality. And, you know, I think this is an interesting issue. I guess I sort of understand why additionality is a big issue with some nature-based kind of approaches, right? If a seed falls in a forest and there's not a carbon credit to support it, like a tree still may grow. But these, you know, these DAC facilities do not construct themselves. And so then the question becomes, well, is the CDR purchase financially additional? And I understand the motivation for that question, but it does feel pretty academic to me relative to where we are. You know, these credits are, in reality, what happens when you go to build one of these facilities is you put together the financials of it and then you try and find investors for it. And it's not so easy to discern what is additional. You know, if the facility has a 8% rate of return without the CDR, and then with the CDR, you have a, you know, 12% rate of return, that very well may change the calculus of investors, whether to participate in that facility or not. And the, you know, the thinking of those investors is not, you know, they rarely say, if it's 10%, we will do it. If it's less than 10, we won't. So I have been surprised that this has been kind of something that we're asked repeatedly by CDR purchasers, because it feels like this is a downstream issue. It feels like this is an issue we need to face when there's a bunch of groups that are doing megaton scale projects, and pulling carbon out of the atmosphere has gotten so cheap that everyone's going to be using these approaches anyways, regardless of whether or not there's CDR purchases attached to it. So that's just as an example, is something. I think there's a few areas where I found, you know, purchasers maybe more worried about downstream projects problems than I am, where I'm, you know, we're just trying to build our first facilities, and like the notion that, you know, one day DAC is going to be so cheap and CDR is so cheap with these co-benefits that, you know, it doesn't do anything at all to enhance the financial success of these projects is not where my head's at the moment. I understand the motivation, but it seems a little slightly far afield from my current set of problems.
Yeah, I mean, what you're saying there just speaks to the broader issue of how unusual of a thing is that we're putting steel in the ground in places, and there's still fundamental definitional, where does CDR fit into a broader sort of policy net zero target that we're it's cliched, but you know, we're building the plane while we're trying to fly it. And there's downsides to that, but I'm also discovering there's huge upsides, that there's a kind of an urgency and intensity of trying to figure these out. It's not, you know, I came from a solar background, which moved fast, but this is warp speed compared to that in terms of how people are trying to cover all bases in smart ways. Danielle, I didn't know if you had anything, particularly with your field orientation. I'm curious if there's anything.
Yeah, I think Luke had touched on it a little earlier. I think what sort of surprised me most is that when we're talking a lot to project partners, so groups that are interested in building a facility like with us, they're most motivated by things other than the carbon credit. So they have a problem, they have a brine problem, they have a water shortage problem that they want solved. And that is why they approach us. The carbon credit is sort of the added benefit to them. And so it's surprising, but it's also comforting that there are these, you know, we can move forward without, you know, whatever happens to the VCM, whatever happens to carbon policy and how long it takes to sort of catch up. These projects are in demand because they solve problems to real industries and real companies now, and that's sort of irrelevant of the voluntary carbon market.
If I could just ask you that too, just in terms of your approach, let's take Palmdale as an example. Are you walking in the door there? We're saying, I have a water solution for you that, by the way, also is climate positive, or, I'm just curious about how that's sort of proportioned in terms of how you
Yeah, definitely. I mean, their challenge was this brine problem, and we can be the brine solution for them. So, the messaging changes a little when you're talking to different partners, but you're trying to solve their problem, and that's what they want to see, right? So, that is kind of how we tailor it.
I love that. It's a very enviable position to be into. But go ahead, Luke.
And Chris, just another example, we have a project in Australia, and the project partner there is, creating hydrogen and green ammonia, and those things require fresh water. And so, there are these, I think, where our projects are really exciting is, where these kind of, your treasure is our trash and vice versa, and these kind of circular economy prospects.
Absolutely. All right, Tank, we do have a good, not a ton of questions, but some very good ones with some pretty good spread in terms of what they're asking. Where should we start? Oh, I think you're on mute.
Sorry. Yes. Thank you, Chris. I'm going to start with this question from Meg, talking about the fate of the concentrated salt in the Capture6 process. Where does it end up? Is it being injected into deep wells? And by salt, she meant sodium and other quote less desirable ions. Can you speak to that a little bit?
Yeah, sure. I can take this one. So yeah, the salts comes in from the brine. Through electrochemical processes, we convert that into the solvent. So if you're following that Na molecule, right, it goes from NaCl to NaOH, that's sodium hydroxide. That reacts with carbon dioxide in the atmosphere, and it creates sodium carbonate, Na2CO3, and that is one of the forms that we can inject the carbon into the ground. The sodium carbonate can also be converted into calcium carbonate. That's just limestone. You can think of that as super stable. So that's another way we kind of think about potentially storing our carbon, because it's a really stable molecule and helps kind of that durability. And so, yeah, the salt goes through this transformative process, and it ultimately gets stored. There are, I think I'll leave it there.
Excellent. Tank, what do we have next? We do have a few other questions.
Here we have one from Nisha. She had a question about energy use. So can you elaborate a little on the energy source, the input?
Yeah. So I did mention, DAC is an energy intensive process, and that's true for our technology as well. Though what I would say differentiates us from some of our other DAC competitor technologies is that we can run our entire system at essentially ambient temperatures, which means we can source all of our electricity, all of our energy from electricity. And so part of our kind of project development, and particularly when we're thinking about scaling up, is to think about renewable energy resources. I think Luke mentioned the project in Australia. One of the things they are doing as part of this green hydrogen effort, and they're partnering with us on the freshwater side, is creating a solar farm. So that was already in the works, and we're going to be able to tap into that renewable energy to power our system. We don't need any thermal energy, so no sort of burning of diesel or natural gas to kind of make our technology work.
And I might just add a couple things. One, I think there's often a perception by policymakers that DAC and these technologies are going to pull basically renewables from the grid and, actually impede decarbonization rather than support it. And I think some of the projects that we're trying to do attempt to counter that narrative, because we are actually by being long-term off-takers of renewable resources, we are basically helping those renewable developers develop a larger solar farm. So I think that's a really important narrative for the community as a whole to challenge, because this is a big critique of DAC, and it's not a completely unfounded critique. So, we're also trying to really think hard about how we can operate on fully intermittent renewables. Another kind of technical thing to think through is when you're, doing the life cycle analysis, how much of that unit of energy do you apportion to DAC versus to freshwater production? If there was going to be a water facility that was producing fresh water, that would have required energy. So a slight complication in our process is how we, the life cycle analysis and kind of the MRV aspects of thinking about how you allocate those units of energy to a process that is accomplishing multiple outputs.
Well, we got Tank a wave of fresh questions that just came in, and I do want to prioritize those. I think Nisha did ask another great question about biggest challenge, which maybe we'll save for the end because I'll sort of tag on my policy question for that. But where should we go next? In order here? Or?
Yeah, let's go to I think George's question. George asks, how does your expected cost of fresh water compare to the reverse osmosis focus on water only?
I'll say one thing, and then I'll let Danielle give a more substantive answer, which is it's probably not. We don't see ourselves as like competing generally against reverse osmosis. There is a point of salinity that reverse osmosis is no longer effective. So, we are basically processing generally higher concentrations of salt than, reverse osmosis is typically effective at. And in doing so, we're dealing with this, brine management problem. So, in general, we see ourselves as complementary to this technology, not sort of competing with it. I don't know, Danielle, how would you answer that question?
I mean, I think that the cost of fresh water varies, a lot depending on where you are. And so I think the folks that approach us looking for a freshwater solution, freshwater is really limited supply, and the cost kind of increases based on that. In areas with ample freshwater resources, the freshwater aspect of our technology is a little bit less interesting, but maybe there are other aspects that are drawing them into the projects.
Great. Tag, I know we do have another technical question from our buddy Sue that Daniela did answer, but it might be worth answering. Having Daniela do that.
Okay. Yeah. So Sue asks, what happens with the Cl when the NaCl becomes NaOH?
Yeah, so as I put in the comments, so if we follow the Cl kind of path, that becomes HCl, hydrochloric acid. That can be reused on site. So there's a lot of clean in place processes that use HCl for cleaning membranes, et cetera. At larger quantities, we can sell it, and we have been talking to different off-takers that are interested in buying this green HCl, which it can get credit for because it is created from the direct air capture process.
And probably worth noting, when we get to gigaton scale, then we, we're gonna that market is not going to exist at that level, but there are a number of neutralization pathways that we're pursuing.
Okay. I have a question about this. Is this a specific to the Monarch project, or would this be the same across all the projects around the globe?
It is similar to the products across the globe. So if you think about the basic electrochemical process, you're taking salt and you're splitting it into an acid and a base. The acid side of that discussion is generally HCl, even with sort of different configurations. But with some of these other different byproducts, the HCl sometimes can be consumed through that process. So in Monarch, the process is pretty simple, and we have HCl just produced. But in some of the other sort of configurations, sometimes the HCl can be consumed.
Great.
Including to basically react the HCl with the carbonate, which is a neutralization reaction that actually creates pure CO2.
Yeah.
So then that can be useful, in a water facility that consumes some CO2, or as, a feedstock for e-fuels or something like that.
Great. Well, I think we're probably at time, unless we can squeeze in Sebastian's question. What do you think, Tank? Do a quick one on that, or the challenge question. That might be a good one to end on.
Well, we could see if we can answer Sebastian's question quickly. How do you see your company and technology evolve as carbon pricing and carbon credits market expand?
I mean, obviously at present, we, like many DAC companies, are kind of pursuing these like bilateral pathways for selling CDR. And that's kind of what we envision for the near term. In the long term, it would be great if the market was such that we don't have to worry about that, right? We do our thing. We develop facilities that generate CDR, and the market kind of takes care of the rest. So hopefully the market over time will evolve to that. I saw just from COP29 yesterday, there was some good progress on Article 6.4.
Great. Well, there's so much more we could ask. And what I'll say is, Nisha had asked, and I wanted to bring up too, is that, this is such an exciting company with an incredibly exciting space that's moving really at just sort of warp speed compared to other sectors of its kind. So that's good. But there are a lot of challenges that lie ahead, and a lot of them that do require a policy resolution. So
Yep.
I'll make this as sort of a pitch. Open air has probably been the source of, most of the CDR support legislation that's been introduced in the US at the state level. And we intend to continue and to grow that in places like California, New York, Massachusetts, Washington, all over, wherever there's opportunities. So please do click on that Discord link and seek us out if you're interested in being involved in activism. We've been quite successful and have a big plate of initiatives for 2025. So I want to thank Luke and Daniela. Really, really appreciate you kicking off this new season for us. Fascinating technology, and we wish you well and hope to have you back when you have the Palmdale facility commissioned. But thank you so much for joining. And I will go ahead and just share my screen right now to tell you a little bit about what's coming up next. We have, again, we're scheduling a bunch of This is CDR presentations for Tuesdays coming up, if you guys can see this. Next week, we're really excited that we have the announcement of the launch of one of Open Air's really signature programs, one of the coolest ones I think we've ever done, that was led and started by my Open Air co-founder, Matt Parker, but with a great team. Sue Dorward, who's asking questions, is going to be on the other side of the screen next week. And the Carbon Removal Challenge is this really interesting university-based competition where student teams from all over the world propose unique carbon removal technologies or designs that they're working on. And they're jury selected, and the finalists are all flown to New York for a presentation. So it's a really cool project. So they'll be talking about what that's going to be like for 2025 and opportunities for both students and judges. After that, we're going to continue to book these. Again, the 19th, we have the Carbon Removal Challenge. On the 26th, we're really excited to have CDR Jobs come in. It's a first of a kind, not just the jobs board for posting employment opportunities within the CDR space, but it does a lot of sector analytics to determine what kinds of jobs are needed and where. And it publishes that data, which is really a really important insight for a small but fast growing field such as ours. Then on December 3rd, we'll have Fallow Labs, which is a really fascinating micro building integrated direct air capture technology based in New York. And so we have a whole bunch of others that by next week even we'll be able to show you a larger calendar. I believe Tank would have put in the link to our Luma, where you can see and register for any upcoming open air events, including This Is CDRs. Just a couple of other things. Open air is really big in the concrete space. We've passed some of our first legislation was focused on concrete decarbonization and the intersection with carbon removal in that material. And we have a sort of an informal group of activists called the Blockheads that meet up every couple of weeks. And we actually tomorrow have a special webinar workshop on some new building code that we think is conducive to advocacy in this area. Tank will drop for that. And I think that's all we have. So with that, I want to thank everybody again for joining, and we'll see you next week.